Here are the instructions in this document. Here's an SRA database. Boom. Contains a gene that includes these fragments below. There are the fragments. There's 10 of them. Pick one. Pick a different one than somebody around you. Fine. Extend it by 200 forward and 200 backward using blast n. So let's see how to do that. And the way you do that is step one, you go to blast, and so you're going to go to nucleotide blast, which is blast n. In the little box, you're going to paste the sequence from that list. You're going to change this, which is going to be on NR. You'll change it to SRA, and you'll change it to the SRA that it says in there, which I believe it is this one. And so if you, there we go, paste that in, it should come up, and boom, you got it. If there's a space at the end, you'll have to delete the space, and then it should appear. If it doesn't appear, you're having connection issues, give it a sec, and then it should work. Highly similar is a good thing. We don't need to adjust, I don't think, any of these. Actually, bump that up. It starts at 100. Actually, yeah, 100's fine. We don't need to change those. We can turn off the masking for low complexity and lookup table. And I like to show results in a new window because that's just how I am. So you're going to hit blast. You're going to get a results page. It looks something like this. Okay, there we go. And so what you do with the results page is you're going to go to the alignments tab, and you're going to align it by flat query anchored with letters for identities, so we can see what lines up with the sequence that you put in. So the sequence you put in is at the top, 1 through 64 in this case. The sequences that align are shown here. So there you can see one that's going backwards, 91 to 150. So that's great. Here you can see one that's going backwards as well, backwards. And this one's going forward. So it doesn't matter. We can pick any one of these. We can pick all of these. So these sequences we can probably use to extend this way. This sequence we can probably use to extend in this direction. So let's just extend in this direction. And so I'm going to open it in a new tab rather than just opening it and replacing this page. And so here we are. This is the new tab, and it's the point 1 that is actually overlapping. So we would copy that. I would find the part that actually does overlap. Let's see. So it ends at AGCT TGTT. So AGCT. There it is. Everything after that sequence is brand new sequence, and look at that. In one fell swoop, we got about 100 nucleotides, and so we are halfway there in extending this to the 3' end. All right. Carry that on for a while, both forward and backward. Remember, to go backward, you're going to need to reverse complement using the reverse complement tool. You just copy the sequence like this one, you paste it into the reverse complement tool, hit reverse complement, it'll give you the sequence, and that now should line up with the sequence that you are building. I would build this in a Word document or a Google Sheets document. Just something you can save as a .doc or .docx. That would be fine. Anyway, you're going to then take this thing, and let's look at the results. So here's the one that you are going to attempt to build out. Just pick one of those, doesn't matter which. And this is my one that's fully built out. So there we go. That's the sequence. And then the next thing you have to do is you have to make an alignment of this. And so, bam, there's the alignment of this. You're going to select all if they're not already selected. You're going to go to the alignments tab. On this one, you want to do flat query anchored with dots for identities. That's going to show us any mutations that exist in this data set, and that's going to be useful. Give this a second, it should load up, and then we can actually see those identities or lack thereof. Meanwhile, we'll pull this up and see what it's going to look like. So it's going to look something like that. So this is showing that we have the sequence ATTA. If it's the same as the query above, it's just going to put a dot. If it's different, it'll put a letter. So if there's a little A here, that means there's a mutation of this T into an A. That's all it means. You're going to screenshot some part of that shows like the thickest alignment with the highest read depth. Like, just eyeball it, whichever part seems to have the most dots. I couldn't even fit mine entirely on screen, and so if you have the same problem, that's fine. Screenshot what you can get, and then you're supposed to take that and you're going to feed it back through BlastX. You'll send it into BlastX. You'll BlastX against the NR database right there, which is going to be the default. And in my case, it didn't find any similarity. Oh well. That's a thing that happens, and that's fine. It's not our job to decide what the result should be. It is only our job to accurately report on that result. And so rather than screen capping my results page, which was the goal, I'm screen capping the results page showing there are no results, and we need a sentence of analysis. So this didn't give any hits from the NR database, and your results may differ. Yeah. And there you go. That's all you need for the entire report. It's probably about 15 minutes work if you know everything that you're doing. I would imagine, though, it'll take a little longer, and that's okay. This is a learning process, and you've got this. All right, thanks.